So what is machine learning? Okay. So machine learning is a subset of artificial intelligence. Okay. But what is artificial intelligence? So artificial intelligence is the science of making machines capable of performing tasks that are normally require human intelligence or that can mimic human intelligence. Like, for example, a human can do the reasoning or problem solving or decision making. So basically, artificial means it is mimicking the human intelligence. So what are some of the examples? Like we can see day-to-day examples, like some of the virtual assistants we can have in our mobiles, or chatbots, okay, or some game playing AI, and many such, okay, self-driving cars, and there are some many such examples of artificial intelligence. Okay, so there are many use cases of artificial intelligence. It can be in many different sectors. It could be in healthcare or finance. For finance, like for example, fraud detection and automated trading. For customer support, AI chatbots handling customer queries. For education also, personalized learning platforms. So AI can be, the artificial intelligence can be very much used, and it is having many use cases in many such different sectors. Okay. So yeah, now this word generative AI, you would also have heard. So generative AI is a subset of AI that focuses on creating some new content like text, images, audio, code, video, using the patterns learned from the data. Okay. So data analytics, this word, it is not, it cannot deal with huge amount of data. Like there are many different types of data, no? Structured, semi-structured, unstructured data. But the data science, this term, since it is having many different statistical techniques and many different methods, algorithms, it is much more enhanced version of data analytics. Okay, that is what data science is. So generative AI, basically, it is generating some new content. Okay, not just like the AI is just like the it is, of course, AI is a huge domain and there are many subsets in that. Generative AI is one, then the machine learning, deep learning, natural language processing, many such subsets are there. But generative AI is what it is generating new content based on the past data, using the patterns from learned from the past data. So instead of just analyzing or doing analysis and classifying something, generative AI generates some new data. Okay, some examples are like ChatGPT or DALL-E, Midjourney, and GitHub Copilot, Gemini. Many other examples are there for generative AI. Okay, so there are many such use cases of generative AI. Okay, and what is the relationship between AI, ML, and generative AI? So AI is a broadest field, okay, and it includes everything from rule-based systems to learning systems. So machine learning is a subset of AI. And what is the goal of machine learning? So basically, we make machine learn patterns on the data instead of hard-coded rules. So automatically, the machine it learns patterns from the data. We don't have to manually write all of the rules. Okay, automatically it learns from the data, and we guide it how to learn. That is the that we do. That is called modeling. Okay, for example, there could be predicting house prices or spam detection. So these are all examples of machine learning. It learns from the data. So based on the past data which we have provided, for example, we have provided a lot of data of house prices. So there can be many factors, many features can be there. That okay, if a house is situated in so and so city, and what is the locality, and how much is the square feet, so how big is the house, okay, and how many bathrooms are there, or many such whatever things are there in the house. So based on that, the prices will increase or decrease. Okay. So many such factors are there through which the price is predicted. Okay. So this is what machine learning does. It will learn from the data which we have given, for example, house prices, and then when we will give some new data, okay, when we will give some new features that okay, these are the factors. Now tell me what will be the price. Okay, what will be the predicted price? So it will tell the predicted price. So how much the data or the data we have given, the correct data and very good data we have given. So based on that, it will learn it. Okay, and then it will give the proper price of the new house. Okay. So this is the machine learning. It learns patterns on the data. Okay, and deep learning is what? It's a subset of ML. Okay, and it uses not statistical techniques. Machine learning will use statistical techniques for predictions. But deep learning, there is something called neural networks. Okay, so these neural networks through that to learn from large and complex data. Like there can be unstructured data. Yes, like for example, image generation, like image, there are images. Then there are many such different types of complex data and very large data. So at that time, we will use deep learning. Even for speech recognition, for face recognition, we will use deep learning. Machine learning cannot be done because it is having only the statistical techniques. But for this, it requires something called neural networks. So to how there are many algorithms, how the image is actually broken down. Okay. So for example, convolutional neural network there is, then how it actually breaks the images. Okay, and then we can understand okay, this is the image of cat, and then after that we'll classify okay, this is a cat or this is a dog, like that. So there are many such algorithms in deep learning. So for more clarification, that in subsequent classes I will explain. And generative AI basically is a special application of AI, okay, built mostly on DL and ML. So based on the data learned, it will generate a new content. So that is what basically that is the interconnection between AI, ML, generative AI, and deep learning. Okay. So that is what the machine learning is what actually. So machine learning enables computers to learn and make decisions from the data. Now, how can a computer learn? What is the process? So by using algorithms, okay, which is a set of instructions for a computer to follow. Okay. So there are different algorithms which we will feed, and we will tell how to learn from the data. So that is what algorithms are. We will give some set of instructions that if you find such pattern, okay, then if you like, there are so many things that it's a very complex subject matter. But when we will give some set of instructions for a computer to follow, it will automatically then generate some groups or it will detect the patterns. So based on the algorithm, we have actually given it. Okay, and which algorithm will fit best or which algorithm is best to be applied for some data set, that gradually we will understand. Okay, but basically through algorithms only, the machine learning or the machine learns. Okay. Now, what is data science? So what does data scientists do? So the data scientists, they know how to apply algorithms. Mean they are able to tell computer how to learn from the data. Okay. Yes. Now, machine learning algorithms, it falls into two broad categories. What are those two broad categories? One is supervised learning and another is unsupervised learning. Okay. So, one second. So, yeah, what is supervised learning? Supervised learning means using historical data to predict the future. Okay. So basically, supervised learning means it's a label data we will give. Okay. So we will give some label data. One second, I have that slide here. Is it there? It's somewhere else. Yes. Okay. So supervised learning is basically uh, supervised learning means it will learn from labeled data set. Okay. So for example, what will house prices look like for the next 12 months? Or how can I flag suspicious emails as spam? Okay, for regression, or regression basically means that it will find some relationship, okay, and it will draw a best fit line. Okay, so that's what regression means. And then classification means that it will classify, is it a spam or is it not spam. Okay, so that's what supervised learning means. Means basically we will be having some labeled data. So already the data set will have that, for example, there is this house prices. Okay, so house prices, in that we are giving some factors or we are giving some features, and then um, there are prices also. Okay, that okay, these are the factors and this is the price, and there are many such rows in the data set. So it will draw a best fit line. Okay, and then it will understand, okay, if these are the factors and this is the square feet and many such factors, so now this is the price. So we are giving the prices also. Okay, now when we give some new data or some new factors we will give, then it will predict, okay, this is the price of this house. Okay, so that is what label data means. We are giving, already we are labeling the data, or we are already assigning, okay, these will be the values. Okay, unsupervised learning means unlabeled data. Means there is no, so we have not done any labeling, or we are not giving that this will be the output or like that. Okay, we are telling that machine only itself can find some relationships or patterns on the data. For example, there are some customers, okay, and we want to segment the customers. So based on their activity or based on what they have done in the data set will be shown. So based on that, it will group them. That these are the high stake customers. So these are the very important customers for us. So these customers, they come very rarely, not much. Okay. So in this way, automatically the algorithm, the machine learning algorithm in the unsupervised learning, it will automatically segment the customers. Okay. Or for example, which TV show should I recommend to each user? Okay. So it will automatically see uh, if a customer, if it is clicking on that movie, or it could be TV show, so then next time in that way only I have to give some recommendations also, or like that. So in this way, this is the unsupervised learning. We are not giving any labels to it. So these are the two broad categories of supervised and unsupervised. So there are many machine learning common algorithms that data scientists use in practice. So in supervised learning, there is regression and classification. These are the two types. In regression, there are different algorithms, which are linear regression, regularized regression, time series. Okay, and classification. So in classification, we are having binary classification. Means, for example, is it spam or not spam? Like that. So there are two things in classification. So then there are k nearest neighbors, then logistic regression, then tree-based models, okay, decision trees, then naive-based algorithms. So then support vector machines and neural networks, deep learning. Okay, so there are many such supervised learning algorithms. Then similarly, we have unsupervised learning. So those are k-means clustering, hierarchical clustering, anomaly detection, matrix factorization, then principal component analysis, and recommender systems, topic modeling, yes, and DB scan. So there are many such unsupervised learning techniques. Okay, so what is the workflow of the data science? Okay, starting from the data until the predictions and until giving the correct output or correct predictions, accurate predictions, and sharing insights, okay, important insights for businesses to leverage. So this is the workflow of the data science. first of all, scoping of a project, gathering data, then cleaning data. Fourth one is exploring data. Fifth one is modeling the data. And sixth one is sharing insights. Okay. So basically, scoping a project means, first of all, we have to have some objectives. Okay. So first of all, we have to define who are your end users or stakeholders. Okay. And who are going to be benefited. Okay. By your model or by your project. So who will be benefited by that? And what business problems are you trying to solve? Okay. Then is this a supervised or unsupervised learning problem? Okay. Then what data do you need for analysis? Okay. So these are some of the questions you will answer and you will brainstorm and you will come to some conclusions. So this is what is the process of scoping a project. Okay. Basically, you try to understand whom you want to benefit and what exactly which problems your business is facing. Okay. And which problem it is it a uh, are you having some labeled data or is it unlabeled data? Okay. Or you don't have any such labeling inside that. Okay. And what data do you need for your analysis? This is also very important. So any data you cannot just select, otherwise your predictions will be inaccurate. Okay. So these are some of the factors you have to consider in the project. Then there is gathering the data. So gathering the right data is essential to set a proper foundation for an analysis. So data can come from various sources. Okay, it can be some Excel sheets, or it could be some text files, or there can be some huge databases. Okay, or it can be some website scraping data. From websites, we can have some data. Okay, and then we have some APIs also. So through this, we have to properly gather the right data. If you gather the wrong data, which is not much useful also, then your predictions also and whatever actions you take based on that, it will not actually work out. Okay, that's why gathering the right data is very much important. Now, usually, whatever data we will gather, it will not be very much clean. Okay, it can be very much messy data. Okay, so that's why there is a need of cleaning the data. So cleaning the data is very much important. For data cleaning, what does it include? So basically, it includes that we collect the data types. Okay, then we will impute the missing data, or so we will replace the missing data with something. Okay, otherwise it will show some error. That's why whatever data is missing, we have to replace it with some value. It could be some mean value or some other value we have to put in the wherever the null values are there. So wherever values are missing, there we have to handle the data carefully. Okay. Then dealing with the data inconsistencies. Okay. Then reformatting the data. So this is all the data cleaning process. And usually the data scientist, they will spend so much of their time in data cleaning. When the data is cleaned properly and when we have chosen the right data from the proper sources, then it will be then the next step will be how we have to model the data. Okay, which algorithm we have to put so that the predictions can be accurate and the error or the inaccuracies can be less. So that's why data scientists, since they will deal the data, so that's why they have to spend a lot of time in cleaning the data. And after the data is clean, then we will build the models. Okay, whatever models, like it could be supervised learning or it could be unsupervised learning. Okay, or if it is very complex data or it is text-based data, then we will use NLP and many such LLM like that. Or if it is so much of image based data or it could be speech based data, then we will use deep learning. Okay. Yes. Then after the data is clean, so we will explore the data. That is what EDA means, exploratory data analysis. It is all about exploring and understanding the data you are working with before building the models. Okay. So EDA will include slicing and dicing the data. So basically, first of all, when we will feed the data, we have to plot many graphs, different graphs we have to plot. We have to understand how many columns are there, okay, and how many columns are there in the data. And we also have to do the encoding also. For example, there is a categorical data. So categorical data, we have to encode in numbers, okay, in binary numbers like that. So 0, 1 like that, we have to encode it. Directly, if we put yes, no, or some other name data, the machine will not be able to understand. That's why data encoding is also very much important. Okay. Also, after data encoding, we have to do standardization. So there is one technique called standardization. Standardization, what does it mean? Basically, there is a formula through which the data, for example, there are some data which is having the higher values. Okay. For example, you consider house prediction, house prices prediction. Now, in that square feet, the square feet can be so much, like, so numbers can be huge. Okay. Even though it is important, the numbers can be huge. Like there can be 100, 200, 500 square feet like that. And the prices can be also huge, like in thousands or lakhs. Okay. Or it could be not just prices. We can consider some other factors like the locality. Okay, locality, or it could be how many bathrooms are there. Okay, and how many the rooms are there, living rooms. Okay, so these all factors. Now living rooms will be one or two, but square feet will be in hundreds. So then the model will misunderstand. It will give importance to the value which is 100, like more than 100, or how many it is in 100 value. So that model will give importance to that rather than giving the importance to the bathrooms or the other numbers, to the other values which are in the units, not in hundreds. Okay, so in that way data imbalance will happen and the model predictions will be inaccurate. So that's why we have to properly standardize the data, okay, through which the data will be standardized, and we can then the data modeling can happen properly, the predictions can happen properly. Okay, so these all things, standardization and encoding, and we are exporting the data. Okay, we are trying to find the basically all exportation, or we will be doing the summarization of the data, or we can apply some different statistical techniques to the data. Okay, so trying to understand the data. Okay, so this is where the part comes, and then we will, yeah, with the help of the different graphs, so we will visualize the data. Okay, so this is the some factors in the exploited data analysis through which we can find many insights, important insights. So based on that, then we can think, okay, we can apply which algorithm. Then modeling the data. So modeling the data involves structuring and preparing the data for specific modeling techniques and applying algorithms to make predictions or discover patterns. So this is the step where we practically apply the algorithms, different algorithms. Okay. And uh, so data modeling includes the restructuring of data, feature engineering, and applying machine learning algorithms. So basically, which features, okay, or which factors which are affecting our predictions. So at that time, we will do the analysis. Okay, which feature is unimportant, which feature is important. Okay, like this. So in this way, we will properly structure the data. There could be some possibilities where we are removing some column. Why? Because that column or that factor is not important. Or else, if we are putting that column, so at that time the predictions are coming inaccurate. Okay. So this is the whole process, modeling the data. Okay. And when the algorithms are actually applied, at that time some errors are coming. Okay, then we will use back propagation. So back propagation technique we will use, and then we will use gradient descent. Okay, the loss function we will see how much error is coming. Like for example, for regression algorithm, for regression problems, we will use mean squared error. Okay, and many different some such type of evaluation metrics we will use to evaluate the error. Okay. Once we understand how much error is coming, then we will try to again we will see what is the data. Okay. And which feature is actually it's a trial and error process. It's a trial and error process. Okay. So when it is we are applying some algorithms, it is giving some error. Okay. And how much accuracy is coming. Then based on that, if accuracy is low, then again we will come back to the data. Then we will see, okay, which feature is actually creating some problem, or which feature or which factor is unnecessary here for predictions. Okay, so based on that, we will take again decisions, and then again we will apply the algorithm. And then through this way, again trial and error through this process, we will reduce the errors. Okay, and then we will see we will be able to properly give the insights, proper insights. Okay, so the final step of the workflow involves summarizing your key findings and sharing insights with the end users or stakeholders. Okay, so those who will be getting benefited by our the project. So what problem we are solving now? So based on that, we will be giving the insights. So after whatever algorithm we have applied, it will give some insights to us. So it basically means interpret the results of your analysis and share recommendations and next steps and focus on potential impact, not technical details. So basically, this data scientist, after he has applied the algorithm and it has given the predictions, so it will give the proper recommendations later on. Okay, so this is the thing, and based so currently what you do, you change this, and then whatever sales are there, it will increase. Okay, or if you remove this factor, if you don't do or apply some new technique, okay, or introduce some new system to the sales team through which sales can be increased. Okay, and what are the problems exactly are you are facing? And what is exactly the reason why the customers are not choosing some course or choosing that product? Okay, so some insights, these insights it will give, and then the data scientist will give the uh, recommendations. Okay, give the recommendations to the customer team or whoever team is there in the business. Okay, so in this way, the businesses can be very much improved. So this is what is the data science workflow.